Spaceflight, eh? It really is something else, isn't it? I mean, the sheer audacity of it all, and of course the ever-present dangers.
Yes, indeed.
And perhaps nothing captures that quite like the launch of Apollo 12, would you say?
Good example to be sure.
I mean, President Nixon himself was there, to watch it all unfold.
Really underlined the significance, didn't it?
Absolutely. No one had a clue about the drama that was about to, erupt, really.
Oh, quite.
So, Apollo 12. Second crewed lunar landing, of course, hot on the heels of the monumental Apollo 11.
It was building on that success, of course.
But it was far more than just a sort of repeat performance.
Much more ambitious this time, in a number of ways. Scientifically, technically.
And even the timeline, underwent a bit of an adjustment, a postponement, actually, and rather deliberate shift, wasn't there, in the training for the astronauts.
Oh, yes. A much greater emphasis placed on geology.
Precisely. And for our deep dive today, we've got quite the collection, haven't we? Notes, mission reviews, all sorts.
Quite a comprehensive set.
Aim is to, dig deep.
Yeah.
Really get into the nitty-gritty of those pivotal moments.
The make or break moments.
Exactly. And we're focusing on especially, captivating aspects today, wouldn't you say?
I would.
First up, those unprecedented lightning strikes. I mean, can you imagine? During launch.
Almost unbelievable, really.
And then that extraordinary recovery. We'll get into all that, of course.
Yes, must unpack that in detail. Quite a story.
And then that pinpoint lunar landing.
Ah, yes, the precision of it all. Remarkable, really. Right near Surveyor 3.
And of course, retrieving parts from that probe. Fascinating stuff.
Gave us an incredible glimpse into the long-term effects of the lunar environment.
So by the time we're done, you should have a crystal clear understanding of those critical events, the expertise involved, both on the ground and in space.
And, of course, the scientific outcomes of the mission.
Right. Launch sequence then, November 1969. The conditions were, shall we say, less than ideal.
Putting it mildly, perhaps. Rainy, overcast skies. And those winds, oh my. The sources mentioned strong winds, something like 151.7 knots. Not exactly what you'd call a textbook launch day.
Not at all. And then, just 36.5 seconds after liftoff, the first lightning strike. Imagine that.
The Saturn V itself was the trigger, you see? Static discharge created a pathway for the lightning.
And the result? Immediate. And, rather severe.
Oh, it knocked out all 3 fuel cells. Entire spacecraft running on batteries, power reserves, meant for short bursts, not sustained operation.
Blimey. And hold on, it gets worse. 15 seconds later, 52 seconds into the flight, a second strike.
This one had a different effect. Knocked out the 8-ball, the attitude indicator. You know how the crew figures out their orientation.
Yeah.
And at mission control, the telemetry went haywire. No one could tell what was happening up there.
Chaos, I imagine. Pure chaos. But amidst all this, the Saturn V itself, the rocket, continued to fly perfectly normally. Incredible, isn't it?
It is. The Saturn V's guidance system was entirely separate, completely unaffected by what was going on in the spacecraft.
So picture this. You're strapped into this tiny capsule, hurtling towards space. A panel of red warning lights. No clue what's wrong. I'd be terrified.
You and me both.
But as they say, a hero emerges. Enter John Aaron, the ECOM, the Electrical, Environmental, and Consumables Manager at Mission Control. The man of the hour.
A remarkable bit of quick thinking, really.
He remembered a very similar telemetry issue from a ground test. Power loss had caused a malfunction in the, what was it? The SCE?
The signal conditioning electronics, part of the command and service module.
Right. And Aaron, he knew the fix. A rather obscure fix, I gather.
He did. Instructed the team, flight, ECOM, try SCE to O. Switching the SCE to a backup power source.
And the switch, was it readily known?
Not really, no. The flight director, Gerald Griffin, had no idea. The KPOM, Gerald Carr, no idea. Even Pete Conrad, the mission commander, drew a blank.
Extraordinary. But thankfully, Alan Bean, the lunar module pilot, he also happened to be the spacecraft engineer.
He was, and he knew where to find that switch.
Thank heavens.
He flipped it, just like Aaron instructed, and just like that, telemetry came back. Mission Control could see what was going on, confirm there were no major malfunctions.
Relief, I imagine. Palpable relief back in Houston.
Must have been.
And then, Bean managed to restart the fuel cells. Full power restored.
Just like that, the mission was back on track. Later analysis showed no serious damage from the lightning. Remarkable.
Quite a feat, wouldn't you say?
Absolutely.
Now, there was some initial concern, wasn't there? About the parachute compartment.
Ah, yes. The explosive bolts for deploying the parachutes during re-entry. There was a fear the lightning might have damaged them.
Catastrophic that would have been.
Absolutely, but nothing the crew could do about it at that point. They decided not to tell them.
Sensible, I suppose. In the end, the parachutes worked perfectly.
They did.
Now, let's talk about the crew themselves, shall we? A rather experienced bunch, this lot.
Oh, yes. Commander Charles Pete, Conrad Jr., veteran of 2 Gemini missions. Then you has Richard F. Gordon Jr., the command module pilot. He'd flown with Conrad on Gemini 11. And Alan Bean, the lunar module pilot, first time in space for him. All 3 United States Navy commanders, naval aviators, test pilots.
Quite the pedigree.
Yeah.
And didn't Conrad and Bean know each other from before?
They did, yes. From test pilot school. Conrad was actually Bean's instructor at one point.
Small world. And they'd also served as the backup crew for Apollo 9, hadn't they?
They had, which of course provided a solid foundation. Teamwork, familiarity with the hardware, the procedures, it all counts.
Absolutely. And then there was the support crew, another layer of expertise, I suppose.
That's right. Introduced during Apollo 9, Gerald Carr, Edward Gibson, and Paul Weitz for Apollo 12, assisting the commander, working on mission rules, the flight plan, all those crucial checklists.
So tell me about the training. I mean, the sheer amount of preparation for these Apollo missions is just mind-boggling.
Thousands of hours. For Apollo 12, each crew member went through over 1,000 hours of mission-specific training, more than Armstrong and Aldrin had for Apollo 11, actually.
And we mustn't forget the time spent as the backup crew for Apollo 9.
And that's another 1,500 hours, yes, all adding up.
Remarkable. And a lot of that training was hands-on, wasn't it?
Oh, yes, over 400 hours in simulators, command module, lunar module, and some of those were run in real time, with mission control, as close to the real thing as you can get. Conrad, of course, spent a lot of time in that LLTV.
The lunar landing training vehicle. The thing that looked like a flying bedstead. Notoriously difficult to control.
It was, but essential practice for landing on the moon.
Now, given the Surveyor 3 objective, geology took center stage, didn't it?
It did, yes. A major focus. Had to understand the lunar landscape, the rocks, the minerals, the processes that shaped it all.
So more time was dedicated to geology training for Apollo 12 than for Apollo 11.
Significantly more. Reflects the changing focus of the Apollo program, moving beyond just getting there towards really understanding the moon.
They had those field trips, didn't they? 6 in total.
Designed to simulate, as best they could, lunar conditions. Practicing sample collection, documenting everything with photographs, communicating with a Capcom unseen geologist listening in, critiquing their techniques.
Refining the process, step by step.
It was, yes.
And after Apollo 11, the crew had a chance to examine those very first lunar samples, right? Must have been quite a moment.
It was. The scientists briefed them, shared their initial findings. Invaluable context for the mission ahead.
It's fascinating to compare the landing approaches. Apollo 11, aiming for a rather broad ellipse. Apollo 12, pinpoint accuracy, a very specific target.
A reflection of the confidence gained from Apollo 11's success, and of course, the Surveyor 3 objective demanded that precision.
Absolutely. And that led to more detailed pre-mission planning, didn't it? The traverses, the paths the astronauts would take on the surface.
4 potential traverses were planned. Contingencies for different landing sites. Always thinking ahead.
So come November 1st, the crew felt ready. It's extraordinary, isn't it? The sheer scale of effort, the dedication, every detail meticulously planned.
A testament to human ingenuity, wouldn't you say?
Absolutely.
Yes.
Now, let's delve into that precision landing near Surveyor 3, a primary objective, as we said.
Indeed. More than just landing on the moon, it was about proving we could land anywhere we wanted. A key demonstration for future missions, especially the scientifically driven ones.
And initially they considered sinus medii, didn't they? Why the shift to the Surveyor 3 site?
Science, really. The opportunity to examine a probe that had been exposed to the lunar environment for over 2 years. Jack Sevier, the planning coordinator, and engineers in Houston, they pushed for it.
But some were hesitant, weren't they? Worried about missing the target. After all, Apollo 11 had landed a bit off course.
Understandable concerns. Landing with pinpoint accuracy was still a new skill. But ultimately, the consensus was that this capability was essential for the long-term success of the Apollo program. Samuel Phillips, the Apollo program manager, he made the final call. Surveyor Crater it was.
And enter Ewan Whitaker, the man who made pinpoint accuracy possible.
He'd already helped locate Surveyor 1, actually, with greater accuracy than NASA themselves.
Really?
Oh, yes. And for Apollo 12, he meticulously studied images from Surveyor 3, compared them to thousands of other craters under a microscope, no less, all to pinpoint the exact location based on the unique arrangement of nearby rocks. Remarkable work.
So Conrad was trained to look for a specific visual cue during descent.
The snowman, they called it. A pattern of craters. Surveyor crater was right in the middle. If he saw the snowman, they were on course.
And lo and behold, November 19th, there it was.
Right where it should have been. Conrad was reportedly astonished. Boosted his confidence no end. He took manual control for the final phase, aiming for Pete's parking lot.
But the terrain wasn't quite what they'd expected, was it?
Rougher than anticipated. A few last-minute adjustments.
But in the end, a picture-perfect landing. Just 535 feet, 163 meters from Surveyor 3. The coordinates are even recorded, aren't they?
3.01239 degrees south latitude, 23.42157 degrees west longitude. Remarkable precision.
Now, one wouldn't necessarily expect this, but the landing actually cleaned Surveyor 3.
Quite a surprising side effect. The blast from the lunar module's engine blew away a layer of lunar dust that had settled on the probe over the years, revealed the original light paint underneath.
Fascinating. Right. Intrepid safely on the surface, Conrad and Bean begin their 2 moonwalks. First order of business, deploy the ALEP.
The Apollo Lunar Surface Experiments Package, a suite of instruments designed to operate for a long time, sending back all sorts of data. Apollo 12 was the first mission to deploy a full ALEP.
And a rather important milestone. This ALEP was powered by a Cessna M27 RTG, a radioisotope thermoelectric generator, first use of nuclear power on a crewed NASA mission.
Indeed. The SNA P-27 used plutonium, reliable, long-lasting power source for the ALEP. Magnetometer, atmosphere detector, ionosphere detector, solar wind spectrometer, dust detector, passive seismic experiment.
A veritable scientific laboratory on the moon. Sadly, the color TV camera didn't fare so well, did it?
No, bit of a mishap there. Bean accidentally pointed it at the sun, fried the sensor. No more TV transmissions.
Shame. But the second moonwalk was dedicated to Surveyor 3, wasn't it?
It was. They went over to the probe, collected several components, including the TV camera, brought it all back to Earth, also gathered some rock samples that Surveyor 3 had photographed.
Must have been a goldmine of data for the scientists.
Oh, absolutely. They could see how materials degraded in the lunar environment. The camera lens, for example, showed micrometeoroid impacts. Tells you something about the hazards of space.
And then, to top it all off, they deliberately crashed the lunar module's ascent stage into the moon.
Controlled impact. To calibrate the seismometer, part of the ALEP, the data helped us understand the moon's interior structure.
A fitting end to their lunar adventures. And then, back to Earth, splashdown on the 24th of November.
Recovered by the USS Hornet. Quarantine, of course, standard procedure.
And the command module, Yankee Clipper, it's still around, isn't it?
Oh, yes. It's on display at the Virginia Air and Space Center. A reminder of this remarkable mission.
And the landing site itself, still there, isn't it? Photographed in detail by the Lunar Reconnaissance Orbiter.
A testament to human exploration, forever etched on the lunar surface.
Right, Dan. As we wrap up our deep dive into Apollo 12, what are your key takeaways?
For me, it's the human element that stands out. That incredible recovery from the lightning strikes, quick thinking, expertise, teamwork. A testament to human resilience.
A close call. And, of course, that precision landing near Surveyor 3, a giant leap forward, wouldn't you say?
Absolutely. It showed we could pinpoint landings on the moon, opened up so many possibilities for scientific exploration.
So a thought for our listeners. Apollo 12 launched in far from ideal weather. Rain, overcast skies, strong winds. Yet they went ahead. What does that tell you about the pressure, the determination, the sheer will to succeed that drove the Apollo program?
It's a question worth pondering, certainly. And if you're keen to explore further, do seek out the images from the Lunar Reconnaissance Orbiter, the Apollo 12 landing site, Surveyor 3, all there, waiting to be discovered. And do delve into the findings from those ALEP experiments. Years of data, a treasure trove of scientific knowledge.
Indeed, Apollo 12, more than just the second moon landing. It's a testament to human ingenuity, our unyielding curiosity, our drive to push the boundaries of what's possible. A truly remarkable mission.